I usually like to say thanks all of you for joining to this webinar for custom bridge modeling, using functional component. This is the second topic for parametric substructure modeling using functional component. In this section, I'd like to detail explain regarding each 2D constraint and type of variable. Also, I'm going to explain model objective and introduce the concept of modular parametric modeling. Parametric modeling is similar with a puzzle game. For example, the puzzle cut is determined by number of components such as cap, column, footing, and file. The piece of a puzzle will be set using 2D constraint, and the plate size is determined by variable names and types. Not only you needed to create 2D profile using constraint and variable, but also verify the expected shapes. The final step is that extrude 3D model from created 2D profile in previous step. Working point and plan are important to parametric model because the shape of the solid will be changed that be based on 2D plan with the constraint. For example, the cubic solid was extruded from rectangular 2D shape, and you were able to define the angle and variable dimension in the plan section. Also, the rectangular just consists of 4 nodes and line. For this reason, you need to assign the constraint and variable to the profile first, and then extrude it for 3D modeling. You enable to use 2D constraint in drawing or modeling workflow. It's really important to understand each 2D constraint because each component will keeping the relationship through the constraint. I'm going to explain how to assign the constraint and how constraint affect to the profile. The parallel only can assign to the line, move to parallel, to assign it to the profile, select the first line, and select the second line. Then second line, move the depth be based on the first line. And select the first line of another 2D profile. And if you select the second line, it becomes parallel to the first line. The meaning is that the first selected line will become parent object, and the second selected line will become child object. The perpendicular also only can assign to the line. Selected the second line becomes perpendicular based on first line. Even though the 2D profile separated from each other, it can make the second line orthogonal based on first selected line. The constant will be able to assign to the line and point. If the constant is specified for both nodes, the second selected node is depending on the first node. And second selected line is depending on first selected node, but the selected node will not connect to the first node. Also, you will be able to assign the constant based on two lines. The tangent can only assign to the line. It will be useful for pylon, tunnel lining, and coping curve. It can connect to the arc and line using tangent. Also, you are able to control the geometry of arc using constant and variable names. The fixed can assign to node and line for working point or controlling the movement. Even though you assigned it to the line, but the line can movable by dimension because it restricted the angle of the line if it assigned to the line. If you fixed assigned to the node, then the point become fixed. Also, assigned the line as a fixed will move over, but the angle of line is fixed. The concentric allow you to matching the second selected line or other shape to center of the circle, and it has a characteristic that is subordinate the degree of freedom, such as constant. For example, I normally use it to control file or drill shaft. You can make the line or line of the figure become to be same length without variable names. I usually like to show you what auto-constraint has the ability. The constraint defined to the section by manually. I'm going to copy and paste. And I remove predefined constraint for this section. Move to setting to select auto-constraint option. And assign constraint. Finally, you can see the section with the constraint automatically defined it, but equal constraint has not assigned it because I didn't select the option for it. Before explain this function, we need a preparation to create parametric modeling. Naming plan is most important one in parametric modeling because the bridge engineer needs more time to take a look at the modeling if the model was created without the rule of the naming and will sharing it. Also, you need to define the base of point for the movement of the shape according to a limited condition. You can assign the dimensions by element with the two alignment method. The alignment will not affect to selected line if the line is parallel to global X or Y direction. And also, you can see how to assign the radius or diameter for a circle or arc. You can also assign the dimension using the distance. The difference from the previous method is to assign the distance using nodes. And also, when you select the distance, you cannot specify the dimension through the line. Enable you assign the distance using two lines if the line were parallel. You can see how to assign the angle and equal distance. I'm going to create two variable names for each angle definition. Because it doesn't allow you can define 0 degree for the angle. Copy the angle to apply to shape. And assign angle to the profile. And verify the shape according to the angle. Also, you can assign the equal distance. But before define this, those line has to be parallel. I'd like to show you the workflow how to create retaining wall using functional component. Move to Setting to modify or confirm the working unit system. And rotate the local axis. Because extruding direction will be local jet direction. I'm creating 2D profile for the retaining wall with the shell key using smart line because the solid model extruded from area element. Create shell key. And complete 2D profile. And this section will move to base point global coordinate 0, 0, 0. And assign the base point as fixed. Putting component will moving same thickness without any the better, so that I'm assigning the constraint using parallel and perpendicular. And create a variable name for putting width. And assigning to section profile. You can see I just define the dimension using 2 line, even though I just select distance. And adding new variable for putting thickness, putting toe, top width, and assigning by element. Adding shell key height, and width. I just specify active value using some real dimension, because the 2D file just created by some correct dimension. If you specify less than or bigger than dimension, and then the 2D profile will be destroyed. So that's why I just using the correct value for active value. Assign shell key height and width, and verify it. Also, you need to verify the movement according to the variable names. Adding footing thickness and modified active value. Assigning it and verify. And modify the constraint to properly. Adding the variable name to specify shell key location. Then you can also change the order of a variable name. And I'm creating the variable names for the stem. Change the type for slope. Specify stem bottom width and modify active value. And stem top width. And stem height. Assign stem bottom width. Using the distance. I had some mistake to specify type, so I just modify the number to the number and then make the formula for the top width underscore 01 and then modify the control point to specify the width. Please be careful to select a dimensional alignment method when assigning the distance. Assign stem height. And verify the shape and movement. There are three types of variables in the constraint tab, such as a variable, local variable, and variation. The variable be used variable names that was defined in DGN library. So you needed addressing the variable name in the library before using it. Local variable is used for external and external variable names. As I presented to you, the external variable is for input, and the internal variable is for the calculated result. Variation is used to pre-specify the series of dimension. For example, you can use it that want to keep the shape, but increasing or decreasing the number of files, and then you can use it. You can see how to each variable will affect to the parametric modeling. I can change the variable name through the item type. And then the dimension will update based on the database. Local variable allow you can change each shape according to variable names, such as I changed some cap length and cap horizontal offset. In the basically, constraint doesn't allow you just put in some negative value, but I'm already created the other lane to calculate the value. I just call some internal variable name. So this variable name already applied in this model. So that's why you can specify negative value for input. And you could predefine the variable value for the series of the model, except for file names, because variable made for partial modeling names. We need a trying effort to improve the performance and reducing man-hour to creating BRIM models. The naming plan allow you will improve the communication between administrator and bridge engineers, because the engineer needs time to aware of the name how those names will affect to the model. And administrator has to test and verify offline model to find out the issue. Also, needed to know the warning message why it occurred when you're testing it. You could see why couldn't assign the parallel function on this shape. I'm already assigned 2 pixel points on the 2 nodes, and they define dimension. And then I will define the parallel. And then, but here, this line cannot move based on this line because define the pixel point and dimension restricting the angle. And change the modeling, why constraint removed from this model. If Cherokee angle is 19 degrees, in true Cherokee height and first Cherokee width divided 3. And adding for Cherokee width as same method. And assign dimension by element. I just defined the dimension. Alignment method is drawing. And verified. You can see the warning message here. Because I assigned the distance using drawing alignment, but you have to assign it with the true for the alignment in this case. So you have to be careful when you met like this warning message. And then I remove the dimension and reassigning with true. And verify the shape according to the angle. I'd like to introduce and suggest the modeling concept for parametric model. It is not easy to consider all of expecting movement in the model. As you want to create the model, then using combine desired each component to apply it other project. For example, each component created such as type of copying, column and putting, and you enable combining it for your desired model. But baseline endpoint has to be same location when you create the model. I'd like to present this concept as modular parametric modeling. You could understanding how each component will combine in OpenBridge modeler. Select custom peer to place the component and select the desired component and placed. And repeat the procedure until complete the combined model. And you need to change height in each cell so that adjust the elevation properly. Change the value per copying geometry. And select column. To change the base height. And change select putting to change the base dimension for copying height and column height. Because I create all of a component that be based on the baseline. Finally, you can modify the variable value for your modeling.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.